So, guys, yesterday, we did, thank you for the shit. Yesterday we did the voltage divider, and we ended with that. And I actually had you do a few problems, right? Didn't I do one where you had resistors of 10, 20, and 30, and you found that so I didn't give you an example like that with the voltage divider? I did? In this period? Yeah. Didn't I give you this problem here where this, here's a 10,
Oh, yes,
here's
you
a,
did.
wait.
Crazy.
And then you get it to 6 and a 2 6 and
Yeah.
yeah.
So this is 24 volts. And so this was 10 ohms, this is 20 ohms, and this is 30 ohms. Remember this? And so you guys figured out that the share, the voltage got divided. This guy ended up being 1/6 of the voltage, this guy ended up being 1/3 of the voltage, and this guy ended up being 1/2 voltage. We did that, right?
Yeah.
Okay, then we're good on voltage dividers. This is the level of knowledge I need you to have. So now I'm going to talk about current dividers. So here we go. Current divider. Current divider. And a voltage divider is resistors in series hooked across a voltage. Well, current divider is going to be resistors in parallel hooked in series with a current. R's in parallel attached in series with a current. Okay. Let me show you what I'm talking about. Suppose I've got some current I, and then the current is splitting into two paths that are in parallel with each other. Suppose this was 10 ohms and this was 20 ohms. The first question I want to ask you is, who's getting the lion's share of the current, the 10 ohm or the 20 ohm? How many people say the 10 ohm is getting the lion's share of the current? Hey, good for you, because current seeks the path of least resistance. So yeah, he's going to get more current than him. So now my question is, how many times more current is he going to get than this guy? Good, 2 times. So I want you to see that unlike voltage dividers, a current divider, it divides the current, yeah, but it divides it in a ratio that's inversely proportional to the ratio of the resistors. That is, this guy gets twice the current. Oops, let me put I. This guy gets twice the current. This guy gets half his current. You see, the ratio of the resistors is 2 to 1, so the ratio of the currents is 2 to 1, only going the other way. So let me write that down. Current is divided in ratio inversely proportional to the ratio of the resistors. I blame the chair. Okay, so let me get you an equation, and I'm just going to do with 2 resistors, because an equation for 3 or more resistors becomes a little bit more complicated, you know. But I'm going to give you a problem with 3 or more resistors anyway. But generally, if I have some current I that's going into 2 resistors, this is R1 and this is R2, then it turns out the current through R1 looks almost the same as the voltage divider formula, except it ends up being R2 over R1 plus R2 times I. And the current through R2 is going to be R1 times R1 plus R2I. It's just kind of the, the opposite of the voltage divider rule. And the reason is, and I'm not going to go through it, though it's pretty easy, but the reason is just because they both have the same voltage drop. They're in parallel. So if he's going to have the same voltage drop as him, but he's got 1/2 the resistance as him, he's going to need twice the voltage. I'm sorry, twice the current. You see? Because they have to have the same voltage drop. Big resistor, small current. Small resistor, big current, same voltage drop. So let me have you guys do a problem. Suppose I have 1.2 amps of current, and it splits into these two branches. One branch is 10 ohms, and the other branch is 30 ohms. Please get me the current through those two branches now. I'll give you a hint. Use these formulas. All right, well, time's up. You know this guy's going to have 1/3 the current as this guy. And so this current here, the current through the 10 ohm, I hope you got that 30 over 40 times 1.2 amps, which is 0.9 amps. So this is going to be 0.9 amps. And I know this has to be 1/3 that, so this is going to be 0.3 amps. How many people got 0.9 and 0.3? Okay, yay for all of you guys. Hey, let me show you another one. What if I gave you this? Let's say this is some current I, and this was a 10 ohm. This is a 20 ohm. And this is a 30 ohm resistor. Well, believe it or not, I don't want to show you the formula. I mean, it's kind of fun, but it's just too complicated for the class, okay? But I just want you to at least be able to make this conclusion. Tell me, what's going to have to be the relationship between the currents going through these two resistors? Like, who's going to get more current, the 10 or the 20? Good. How many times more? Twice as much, right? And how many times more current is the 10 going to have to get than the 30? 3 times as much, right? And how much times the 20 versus the 30? Well, 50% more, right? Well, in order to get the actual currents, it requires some math, and it ends up being that this guy is 6/11ths I, this guy is 3/11ths I, and this guy is 2/11ths I. Are you okay that all of those ratios are good? That's just the way it works. So I mean, I could teach you a way to get that, but it's really not necessary. It's just enough for you to be aware that whoever's got the smaller resistance gets the bigger current, and that's the current divider. Any questions or issues on current dividers? Okay, well then it's time for us to do conceptuals. I know some of you, it looks like some of you are multitasking right now.
Should I stop recording then?
Oh, good idea. Yeah, you know what, let's start here, just a second.